Hi guys! Are you ready to learn about translations today? I know you're excited. I am too. All right, we're going to get started and talk about what is a translation. Translation is a transformation. It's one kind where all points in the image move the same distance in the same direction. All right, so let's look at this example. Here we have this rectangle, A, B, C, and D. And if we're going to fill in the ordered pairs for each of these points. And so if we look at point A, it is at -5, 3. And B is at -2, 3. And C is at -5, 1. And D is at -2, 1. This original polygon is called the pre-image. Pre, we know from language arts, means before. So it's the image before anything happens to it. So we are going to translate this rectangle to this space down here. So A is going to go down to here. In order to do that, we are going to have to translate it to the right. Let's see how many units. We want it to go over to here. So let's count. It's just like when we count slope. We're going to count 1, 2, 3, 4, 5, 6. So we went 6 units to the right. And now we'll count, we want to get it down to this point. So we're going to count down 1, 2, 3, 4, 5. And so we went 5 units down. So after the translation, now we have the points, every one of these points has moved to this in the same direction, the same amount. So now we're going to record the ordered pairs for this. And it's important that you know that this now is called the image. And this notation where you see A with the little 1 up there, or the apostrophe, that means it's called A prime, which means that is the transformed point. That's where the new point is located. So now the point for A prime is 1, -2. B is 4, -2. C is 1, -4. And D is 4, -4. So this point right here, D prime, is going to be read as D prime. So because these two rectangles look exactly the same and they're exactly the same size, the only thing that's changed is their position in space. So because they're exactly the same shape and the same size, we are going to say these two polygons are congruent. Congruent means the same shape and the same size. And because of that, this is called a rigid transformation. Rigid, if something is rigid, you can't change anything about it. It's the same. So for example, my coffee cup, it's rigid. I can't change the shape of it unless I drop it on the floor. I don't want to do that. But in order to have it remain the same, the shape of it is not going to change. I can't stretch it or shrink it, and I can't bend it, okay? That's what rigid means. All right, so let's talk about what this looks like, the algebraic representation. So for example, if we start with x and we want to move it left, if we were to go left and we're at where x is 1 and we want to go left, we're going to change the x coordinate by moving it to the left. So if we're going to move it left 2, x is going to be 3 minus 2, and y stays the same. Your y, it's going to stay on the same spot. So in this case, it would be 1, the new point would be 1, negative 7. For this one, if we're going to move it to the right, then only our x value is going to change again. So we're going to move it to the right 6. So we would have, it would be 3 plus 6 because we're going in the positive direction. Oops, sorry about that. And we'll be at negative 7 again. So then our new point here would be 9, negative 7. Let's talk about if we move it up and down. That's going to change our y value. Our y value, if we wanted to move it up 5 units, x this time is going to stay the same. So this time we'll stay at 3, and y will be negative 7 plus 5 because we're going in the positive direction. The new point then would be 3, negative 2. If we were going to move down, we start here at 3, negative 7. We want to go, move it in the negative direction 3 times down. So our x value again stays the same. And from negative 7, we subtract 3. So there we would end it, the new point would be at 3, negative 10. So by the end of this unit, you want to be able to describe the properties of a translation and how a translation affects the congruence and the orientation of the figures. So as you can see, we know that a translation is rigid because we said we end up with the same exact shape, and it's congruent, meaning it's the same shape and same size. And the orientation is just describing how does the shape, what direction does it face? And as you can see, the orientation stays the same. A is in the top left here, and again, it's in the top left here. So a translation just moves a shape in different directions, okay?